This section is about the reciprocal parent function. So the reciprocal parent function makes the shape called a hyperbola. That's the shape of the graph. So the parent function is y equals a over x minus h plus k. So some key things to look at is that x is going to be in the denominator, okay, of a fraction. So generally, the general shape, if you just had the function y equals 1 over x, your most basic function, so it hasn't been shifted left, right, up, down, or have a vertical stretch or shrink, what you're going to have is this is going to be, if you think about making a table of values, if x is positive, you're going to be in the first quadrant. And if x is negative, the function is going to be in the third quadrant because the y is going to be negative. So I'm going to plot some points here. So if I plug in 1 for x, 1 divided by 1 is 1. So one point that's on the graph of y equals 1 over x is the point 1, 1. Same with if I plug in negative 1, I'm going to get negative 1. If I plug in 2, I'm going to get 1/2. If I plug in a half, I'm going to have 1 over 1/2. That's going to give me 2. So if I go over a half up 2, I can already get that this is going, in the numbers that I plug in as x gets greater, that's going to get closer and closer to the x-axis, but it will not cross. So the general shape looks something like this. It's got arrows at the end, and it's going to do the same type of thing on the other side. So it has asymptotes at x equals 0 and y equals 0. This is called a branch. Right here is a branch, and this is a branch. So this has 2 branches. So I just plotted 3 points on that branch. So I can go over here, and you can look at the graph. The domain is going to be, you can plug in everything in for x, except you can't plug in 0 for x, because if you plug in 0 for x, you'd be dividing by 0. So it's going to be all real numbers except for x can't be equal to 0. You can also write that in interval notation as well. And then the range is going to be, if you look at going up and down, it's going to be all real numbers except y can't be 0 because it's not crossing the x-axis. So the vertical asymptote is going to be this line where it doesn't cross. It's a vertical line. It's going to be the equation x equals 0. And the horizontal asymptote is going to be y equals 0. Down here, we're going to look at how this parent function, what the different transformations do to it. So we talked about that with different functions, about the parabola, a line, an absolute value function, a square root function. H is going to be the horizontal shift. So if it's positive, down here, if this number is x plus 5, you're actually going to go left. So plus means left, and minus shifts it right. It's kind of opposite, but it's been the same for all the functions that we've studied. K is going to be the vertical shift, and if it's positive, it's going to shift up, and if it's negative, it's going to shift down. If A is negative, the function is reflected across the x-axis. So if you're looking, the A is a number that's on top in the numerator. So it could also look like this. If you had this function opposite 3 over x, this A is a negative, so it would be reflected over the x-axis. If A is greater, the absolute value of A is greater than 1, it's a vertical stretch. And if it's less than 1, or between 0 and 1, it's a vertical shrink. Same function rules applies. So examples, write an equation for each reciprocal function after the transformation. So if it's been reflected across the x-axis, transited 2 left and 1 up, it's going to be y equals, reflected across the x-axis, I need to put a negative. It doesn't say anything about a vertical stretch or shrink, so I'm going to write it as -1, and it's left 2, so it's going to be x plus 2, and then plus 1 for up 1 unit. Vertical asymptote of x equals 1. So this means that it has actually been shifted right 1. Okay, so it doesn't read anything about a reflection or any other translation besides being at right 1. So it's going to be y equals +1 over x minus 1 because it has been moved over 1 unit. So if the horizontal asymptote's y equals 3 and the vertical asymptote's at x equals -1, it's going to be +1 over vertical is -1, so it's shifted left 1. And horizontal, it's shifted up 3. 4, it's reflected across x-axis, and it's a vertical stretch of 4. So the a has to be 4, and it has to be a -4 because it's reflected across the x-axis. So it's y equals -4 over x. Vertical stretch of 5, right 1, down 2, is going to be y equals 5 over right 1 is going to be x minus 1. Down 2, I'm going to put a -2 outside. Vertical asymptote at x equals 2. So it's going to be 1 because it doesn't say anything about a stretch or a shrink. And then x minus 2. And then the horizontal asymptote is -5. Okay, down here, I'm going to write the asymptotes. So if I'm moving the function left or right 1, this is going to be x equals 1 is going to be the vertical. And then y equals 3 is going to be the horizontal. X equals, it hasn't been shifted at all, so it's x equals 0 is the vertical. Y equals 2 is the horizontal. This one is going to be x equals -2 is the vertical, and there's no shift up or down. So it's going to be y equals 0 is the horizontal. X equals 0 is the vertical, and then y equals -6 is the horizontal. Okay, in this one we're going to use, we're going to describe each transformation, so reflections, translations, vertical stretches, and shifts. So this one has not been reflected because the a is positive. And it's only been translated down 4. So I just write down 4. Number 2, it's been reflected because that a is negative. So I put reflected. And there's a vertical stretch because the absolute value of -3 is greater than 1. So it's stretch by 3. And then it's shifted left 2 and then up 2. Number 3, it's a vertical stretch. It hasn't been reflected. So stretch by 5. And then it's moving, right 1. And is not moving up or down. Number 4, vertical stretch by 7, and then it's just moving down 6. Okay, down here we get to the graphs. Okay, when you're graphing, what you want to do is first find the asymptotes and then plot 3 points on each branch. So remember, a hyperbola has 2 branches, so you're going to have to plot 6 points total. So this first one is f of x equals 1 over x minus 2. So the vertical asymptote is going to be x equals 0 because it hasn't moved left or right, and the horizontal is going to be y equals -2. So I'm going to graph my asymptotes first. Oops, okay, so since the a value is positive, it's going to be in these two quadrants. We made a quadrants with these blue intersecting lines, so it's going to be in this first quadrant and the third quadrant. So you're taking the function and you're shifting it down to that we graphed on the first page. So I'm going to make a table of values. So what I did is I made a table of values. I plugged in 1, 2, a half in for x, and then solve for y. So I picked positive and negative numbers, so I want to get on both sides of the quadrant, and then or in both quadrants, so then I can connect these points. Make sure you put arrows at the end, and then your asymptote should not cross, or your graph should not cross the asymptote. So I'll do another example over here. So first I would draw your vertical asymptote, so it's going to be at x equals -3, and then your horizontal one is going to be y equals 0. Ooh, I just realized I didn't do the domain and range over here. So the domain and range are going to be, the domain is going to be all real numbers except where the vertical asymptote is. So it's going to be except x can't be 0. And your range is going to be all real numbers except where the horizontal asymptote is, which is at -2. So I'll go back over to this one, and we'll do this one. So my vertical asymptote, I'm going to do the domain. Domain's going to be all real numbers and then, but x can't be -3. And the range is going to be all real numbers, but y can't be 0. So I'm going to draw in the asymptote, so it's going to be x is -3. That's going to be my vertical asymptote. My horizontal one is going to be y equals 0. And then I can make a table of values for my x and y. So or my x and f of x. So I usually, I know it's going to be it's a positive, so I know it's going to be in this quadrant over here, the branches, in this quadrant over here. So I want to pick values that are probably closest to the, where you have this intersection is going to be the easiest. So I'm going to plug in numbers for x. So I think maybe a good one to plug in would be -2. So if I plug in -2 for x, I'm going to get 1 over -2 plus 3, which is going to be 1. I could also plug in -1 for x, and that will give me 1/2. I could plug in 0 for x, and that will give me 1/3. I can't plug in -3 though, because that will give me a number that will not be defined, because that'd be divided by 0. So I'm going to plot -2, 1, -1/2, 0, 1/3. So it's going to go like this. I didn't connect that very well. And then I could also plug in, if my asymptote's at -3, I'm going to plug in -4. So I'll get -1. I could plug in -5. So I'll get -1/2. And I could plug in -6, and I'll get 1/3. So -4 is -1. -5 is -1/2. So like this. So these branches should be congruent. So I'm going to leave up to you to do this last one. Now this will be reflected, because this is a negative. This will actually be in these two quadrants right here. Okay, the asymptote will be x equals 0 and y equals 1, but it'll be in these two quadrants.